Hey everybody, Noodle here. How you doing today? Well, I'm trying to get the lighting good here, so we'll see how it works. Today I'm talking about decimals. Okay. Now decimals have to do with parts of numbers that are less than a whole. Just like fractions, if we say a fraction 1/2, we can also express that as a decimal. Decimal would be 0.5, right? Now, if you need to review that, that's fine. Decimal means 5/10, and that's why we say decimal. 5/10. Why do we say 10? Because the first place value behind a decimal point is the tenths. In decimal form, these are the ones, and then behind the decimal, we have smaller bits. We have tenths, we have hundredths, we have thousandths, we have 10,000ths, and on and on and on. If you need review with that, I recommend it, if that makes sense to you. We use decimals for money, but we also use it for scientific measurement and medicine. Very useful. And when we're dealing with it, let me show you another example, and then I'll get into the operations with them. We have a number like 0.385. This means I have 3/10ths, I have 8/100ths, and then I have 5/1000ths, right? I could also express this as saying 385 over 1,000. See, each place value takes it out to a smaller and smaller measurement, right? So, in money, we usually just take it out to 2 place values. Sometimes in scientific measurement, we'll take it really far out there. Express things that are very, very small. Okay, let's look at how we add, subtract, and multiply and divide these things. It's not too tough. When we want to add them, all we do is line up the decimal points. 1.2 plus 3.4. See? I just line up the decimals and add, as normal. There we go. 3 plus 1 is 4. Good. Add as normal, just straight down with the decimals lined up. If there's a number that has a space, we might have to put a 0. Let me show you what I mean. How about like 8.2 plus 1.05? 8.2, and I line up the zeros. Uh-oh. What do I do about this and this? Can I add those together? Yes, I can. I put a 0 on top because 8.2 is the same thing as 8.20 or 8.20000. If I put zeros behind it after the decimal, it's fine, as long as there's no other numbers out there. And then I just add. 0 plus 5 is 5, right? Just like that. Easy. What happens when we subtract? Same concept. We have to line up the decimal points and then proceed as normal. Suppose I have 3.14 and I want to subtract 2.57, right? I put these in line. I line up the decimal points and then I subtract. I can't take 7 from 4, so I have to borrow. 14 take away 7 is 7, but then I can't take 5 from 0, so I have to borrow. 10 take away 5 is 5. 2 take away 2 is nothing. So I could put 0.57. And you also might see this written as just 0.57. Right? Good. Okay. If you need help with that, what I recommend is stopping the video, going through the problems that I put on, seeing if you get it. If you don't, watch it again. And also, you can make up your own questions and then check it on a calculator to see if you're doing it right. With adding and subtracting, just line up the zeros. It's easy. Now, multiplying and dividing is a little bit more tricky. In multiplying and dividing, we are interested in how many places are behind the decimal. I would multiply 1.21 times 0.08. At first, I'm just going to multiply them like normal. It doesn't matter, if the decimals are lined up at all. Just multiply them like normal. 8 times 1 is 8. 8 times 2 is 16. Carry the 1. 8 times 1 is 8. Plus 1 is 9. And then 0 times, put a 0 here. 0 times those, 0, 0, 0. Right? Now, I did it wrong. It wasn't 0.08, it was just 0.8. Let's try that again. Aha! It's okay to make mistakes. Let's try it again. 0.8. This is even a better example. 0.8. Let that be a lesson. Always look to make sure you're doing the right problem. Okay, here we go. 8 times 1 is 8. 8 times 2, 16. 8 times 1 is 8, plus 1 more is 9. There we go. Now I move on. 0, 0, 0. Okay, great. 8, 6, 9. 0 plus nothing is 0. Now, we can bring it down. Here's the crucial part. Once we get this answer, we have to make sure that it is small enough to be in line with the neighborhood of these. Look at this. I have 1, 2, 3 decimal places behind that decimal point. I have 2 here, 1, 2, 3. So that means I want to move a decimal point from over here, 1, 2, 3. And I put it right there. Why did I put it there? Because I have 3 digits behind the decimal point. So that means my answer wants to have 3 digits behind the decimal point. I just added them all together. So the answer here is 0.968. Let's try another example and see if it works. This time, I've got to try to write down the right problem. Okay, here we go. Multiplying decimals. How about 4.3 times 0.07? Okay, 4.3, and then I have 0.07. Okay, what do? 3 times 7 is 21. Put the 1 here, carry the 2. 3 times 0 is 0, plus 2 is 2. 3 times 0 is 0. Then I move to the tens place. 4 times 7 is 28, carry the 2. 4 times 0 is 0, plus 2 is 2. 4 times 0 is 0. Then I add 1. 2 and 8 is 10, so I have to carry the 1. 3, 0. How many place values do I have that are behind the decimal? I have 2 here, and I have 1 here. So I have a total of 3. That means I have to shrink my answer here. 1, 2, 3. See, I always move it from the right to the left. So my answer is 0.301. There we go. Right? Just multiply as normal, and then adjust the decimal point based on how many numbers, how many digits are behind the decimal point in the original, including both factors. It's a little confusing, but with some practice you can get it. All right. Let's show division real quick here. to divide decimals, let's say I have 18.3 divided by 0.2. Okay. Of course, I'm going to put my 18.3 here, and I'm going to put my 0.2 here. I set it up like a long division problem. Even before I do anything else, I want to adjust this divisor here. I want to move it over one spot. Why do I move it over one spot? Because if I move that decimal over one spot, then I'll have a 2, and that works. I'm going to adjust this the same amount, the same degree. This is moved over one spot, this will be moved over one spot, and I'll put that new spot up on top, adjusting my answer even before we get started. Now, 2 goes into 18, 9 times 2 is 18, subtract, bring down my 3, right? You know how to do this. 2 goes into 3 one time, subtract, and you know what? I could bring down a 0. 2 goes into 10 5 times, with no remainder. So I get an answer 91.5. I've already adjusted, so I don't need to readjust it. This is the answer right here, 91.5. Right. Let me show you one more. And this is kind of a real life example. How many quarters are in $5? We'll look at it. Okay, if you get confused, you can watch it again, make sure. Okay, I'm starting with $5, 5.00. I'm dividing that into piles of quarters. A quarter is 0.25, right? So what do? I put the 5 underneath my bracket. I point the 0.25 out here. How much do I need to adjust it? In division, you adjust it right away. I need to adjust it to 1, 2. Why? Because I've got 2 digits behind that decimal. Well, if I change this, I'm going to change this. 1, 2. And then I put the decimal right up top. Right up top there. Right here. Now I've adjusted it. I can proceed. How many times can 25 go into 5? It cannot. I'll move over. How many times can 25 go into 50? 2. I want to put that 2 up there. 2 times 25 is 50. That gives me, and then I bring down a 0. How many times can 25 go into 0? None. So I have 20. So guess what? There are 20 quarters in $5. Okay. Try it on your own. If you have any questions or confusion, you can put it in the comments here, and then I'll try to help you out there. All right. Go slow, get some practice in, and try problems on your own. And then write them out, give them a try, and then put them in the calculator to see if you got it correct. Okay, good luck with everything.